So we're going to go ahead now and look at 1.3. And we're going to talk about standard form of a complex number. And standard form of a complex number is a plus b I. So when we write these, we have to make sure that we separate out the real part from the imaginary part. So let's look at minus 8, and let's do a plus the square root of, how about minus 16 over 4. I'll make an easy one here to start with. Now, what we do is we go ahead and we break up our square roots. So what's the square root of that minus 16? Well, the square root of 16 is 4. So that's going to come out as a 4i. Okay. And I think this is easier than what we did before break, because we don't have to worry about I squareds. It's just break it up and then reduce. Now the 8 and the 4, they can't go together because remember, this is real and this is imaginary. What we then have to do is break up each part into its own individual fraction, and then we reduce. So what's it going to reduce down to? Well, negative 8 over 4. Negative 8 over 4 is a negative 2. What about 4 over 4? 4 over 4 is 1. So that's 1i, and we just write that as an I. So that would break down and become, in standard form, minus 2 plus I. So you break up your square root, and then you split the fraction into the 2 halves, and you reduce down each one individually. Okay, let's try another one here. And again, we want these in standard form. Okay, let's do a minus 8 minus, how about the square root of a minus 48 over 2. Now, what do we know about 48? Okay, well, we need to break this up. It's an even number, so we're going to start with 2. So 48 divided by 2 is 2 and 24. And then we've got 2 and 12, and then 4 and 2. And 4 breaks down into 2 and 2. Okay, is everyone okay with that? We just break it down as far as we possibly can. So 2 and 24, 2 and 12. Sorry, that should be a 3, not a 2 there. My mistake. I just wrote down too many 2s. So it's 4 and 3 there. Sorry about that. 2 and 2. What do we have? Well, we have a pair of 2s and another pair of 2s. Can I cancel the double negatives here? Can I cancel those out? No. Why not? One negative is in front of the root. One is underneath the root. So that has to stay there. So we have a minus 8, and then we have a minus that stays with it. We have a 2 times another 2. We have an I, and then we have the square root of 3. It's by itself, and that's all over 2. And you could have just wrote down minus 4i there if you wanted. I just wrote that the 2 times 2, so you would see that there are the 2 pairs here. That's where those came from. These 2 pairs went and made that. Now we can do one more step. And so we've got minus 8. We have a minus 4i, square root of 3. Those can go together, over 2. Everything is broken down. Now we split it up into the 2 fractions again. Okay, just break them up, just like we always would. Negative 8 over 2. Okay, negative 8 over 2, that's a negative 4. That's your real part. Negative 4 over 2, that's a -2. The I comes down, and so does the square root. And so that's your final answer in standard form. One more, and then we'll move on to the next section. Okay, how about -12 plus, let's see, how about the square root of minus, how about 9 over 5. So I'll move it up so we can see it here. And this one's pretty easy too. And you're going to encounter questions like this in 1-4. This is going to be part of our answer, but we'd have to break it down. In 1-4, when we use the quadratic formula, you will get out something like this, and we need to write it in standard form. So what do we have? We have a -12. And then what about 9? Square root of 9 is 3. It's negative, so it's 3i over 5. And in some cases, it may not reduce. So you may just have to leave that as -12 over 5 plus 3 over 5i. Because those are not going to reduce down any. And that's all we can do, is just leave it just like that. Because sometimes they'll reduce down, sometimes they won't. But that's the most important concept you need for 1-4 is this. And we're going to be covering more of this on Monday, of how to work with the standard form from what's called the quadratic formula. 1-4 has a lot of different parts to it. And so 1-4 today, we're going to be looking at zero factor. There's 3 basic parts to 1-4. There's zero factor. There is the square root property, which we will be covering next week. I don't think we'll have time for it today. And then also next week, we're going to cover the quadratic formula. So those are all going to be parts of 1-4. Today, we're going to look at the zero factor. And I know that you have saw, or should have seen, zero factor at the very end of your intermediate algebra course. So I know that the last week of the course and on your final, we talked a little bit about zero factor. So we're going to learn again how to solve with zero factor. So how do we solve something with zero factor? Step number 1 is you set to 0. Step number 2 is you factor. And step number 3 is you set each factor to 0 and solve. So those are our 3 steps. Set it to 0, factor it, and then you set each factor to 0, and you solve each part out. And these are going to have several answers. Most of the time they have 2, some rare cases 3, and also in some cases you may have a double root, which would give you then just 1 answer. And I'm just going to pick these from our textbook, just to make it easier. And I'm on page 139. And we'll start off with a very easy one. And we're going to do a lot of these. We're going to start off with question 13. Okay, we want to factor this. And we're going to solve it with 0 factors. So first off, has it been set to 0? Yes. Okay, so that makes it easy. Now we need to factor it. Remember, this is a trinomial. If there's no number in front, we put a 1 out here, and then we multiply. 1 times 6. What's 1 times 6? 1 times 6 is a 6. So that goes in the box. Kind of remember this? Now, what do we know about the signs? 6 is positive, so since this is positive, they are either both positive or both numbers are negative. Well, what's the sign in the middle? Negative. So what do we know? We know then that both numbers are negative. Okay, so what two numbers now? Let's see if we can remember the pattern. What two numbers multiply together to give you 6, add together to give you 5 in the middle?
3 and 2.
Okay, 3 and 2. So we use a negative 3, and we use a negative 2. Now, I didn't show you this in intermediate algebra because I wanted you to go through all the steps. But if there's a 1 here, if this is a 1, you can jump straight to the factors. If it's any other number, you're going to have to do grouping. But this has a 1. Okay, so that 1 out in front has to be a 1 in front. If it has a 1 in front, then I can jump directly to my factors, which is x minus 3, x minus 6, and that equals 0. Okay, so it's been factored. Now we solve it. We set each piece to 0. So x minus 3 equals 0. We add that 3. And so my first solution is x equals 3. Repeat the process for the other one. X minus 2 equals 0. Add your 2. And so x then equals 2. So there's your two answers, 3 and 2. Okay. Question 14. Very similar again. This is going to be the last one where we can just jump to our factors. After this, we're going to have to do grouping. So 14 is x squared plus 2x minus 8 equals 0. And again, we're just going to solve it. So what do? We repeat the process. We take the first number times the last number. No number in front, so we put a 1. And whenever we put a 1 there, this makes it easy. We can jump to our factors at the end. So we take 1 times a negative 8. 1 times a negative 8 is a negative 8. Now, since this is negative, that tells you then that one number is positive, one number is negative. Because you need two numbers to multiply together to give you a negative. And the only way that can happen is if one is positive and one number is negative. Now we look at the sign in the middle. And what's our sign in the middle? Positive. So the larger number is positive, smaller number is negative. So what two numbers multiply together to give me 8? Subtract from each other to give me a 2 in the middle. Yep, we need a 4 and a 2, right? We need a positive 4, because that's our larger one, sign in the middle, negative 2. Now, because we have this 1, we can jump to our factors. So that's going to be x plus 1, or sorry, x plus 4, let me say it correctly. X minus 2 equals 0. And now the hard part is done. So now we can finish it. So set each part to 0. So x plus 4 equals 0. Move that 4 over. So that gives you your first solution, which is x equals now negative 4. X minus 2 equals 0. So move that 2 over. So x equals then a positive 2. Kind of remember this from intermediate, hopefully? Remember in intermediate, too, they can get kind of difficult on the factoring. These were really simple ones. Question 15, we're going to have to do grouping on. And 15, we've got to move things around first. So in question 15, we have 5x squared minus 3x equals 2. We're using 0 factors, so what's the very first step? It has to be equal to 0. So we're moving that 2 over. So that's 5x squared minus 3x minus 2 equals 0. This one now is going to have to be broken down by grouping. We're going to do the same process at the beginning, but because of that 5, we're going to have to break this down and factor it by grouping at the end. So the first step is the same. 5 times a negative 2 is a negative 10. And since this is negative, that means that one number is positive, one number is negative. We look in the middle. Middle number is negative. So negative is the larger one, so it goes first. Positive is the second. What two numbers multiply together to give you 10, subtract from each other to give you 3? Does anyone know the two numbers here? Multiply together to give you 10, subtract from each other to give you 3 in the middle. Yep, 5 and 2. Yep. Can't write it either. 5 and 2. Okay, now, this right here tells me that is going to have to be factored by grouping. If it was a 1, it would be much easier. Because if it was a 1, see, then we could just jump to our answer. So because of that 5, we're going to have to factor it by grouping. And how do we factor it by grouping? Well, when we factor by grouping, what we do is we split the middle up. And what are our two numbers that we found for the middle? Minus 5 and positive 2. So remember how this works. The 5x squared comes down. We split the minus 3x up into a minus 5x and a positive 2x. Those are our two numbers here. And then we've got a minus 2. Now we factor it by grouping. First two pieces, what can come out? Yep, and a 5 as well, right? Yep, so 5's come out, x's come out. So that leaves you with an x minus 1 inside. Next two pieces, looks like these have a 2 in common, so that's going to also leave you with an x minus 1. Are my groupings identical? Yep, they have to be. If these are not the same, you made a mistake. So those are the same. So that's going to come out as an x minus 1. And what's left over? 5x plus 2. And what does it all equal? Still 0. Now we can finish it. Set each piece to 0. So x minus 1 equals 0. These are our factors. So x equals 1. And I'll slow down a bit just to make sure we can all stay caught up here. So that first one, I just moved that 1 over. What about for the second part here? Okay, for the second part, we're actually going to have to use algebra because it is 5x plus 2 equals 0. So we're going to have to move that 2 over. That is then 5x equals a negative 2. Divide by our 5. And what do we now have? We now have our second solution, which is x equals a minus 2 fifths. So these are our two solutions. We'll try a couple more of these. We'll just keep working on these until we run out of time. So we'll probably do 3, maybe 4 more of these. Very, very important we know how these work. We just did 15. Now we'll try 16. They do get a little bit more difficult as we move down. 15 and 16 are very, very similar though. On 16, we have a 2x squared minus x equals 15. So guide me through the process here. What would you do first? Yep, okay. So that's easy enough. Move the 15 over. It's 2x squared minus x minus 15 equals 0. Can anyone tell me what number is going to go in the box here? Yep, and it's not just a 30. Watch your signs. Yep, 2 times negative 15 is a negative 30. And so this 30 is negative. So what do we know about the signs? Are they going to be the same sign or are they going to be different signs? Different signs, okay? So one is positive, one number is negative. Now, which one is larger, the positive number or the negative number? Negative. Why? Because the middle's negative. So we have a negative and we have a positive. Now, we need two numbers that multiply together to give you a negative 30. Subtract from each other to give you a 1. There's no number there, but we know that's a 1 in front, right? So what two numbers would multiply together to give you 30, subtract to give you 1? Now, where do we begin on this? How do we find out the numbers? Okay, look at 30. What does 30 end in? 0. That means it has to have a 5 or a 10 in it. So let's try 5. What if we use 5? It'll work, won't it? Because that would be 5 and 6. So we need a negative 6 and we need a positive 5. Can we just simply jump to our factors? No. So we have to do grouping. So we're going to split up the middle. And it's 2x squared. And then we've got a minus 6x, a plus 5x, and a minus 15. Factor by grouping. First two pieces, can someone tell me what will come out? I've got it underlined here. What's going to come out? X and what else? Yep, 2. And can someone tell me what will be left over here? Well, not just a 3. We've got an x left over, right? And then we have a minus 3 from there, right? Because the 2's cancel. The x squared, we took an x out, so that leaves an x there, doesn't it? Okay. And then the minus 6, well, minus 6 divided by 2, that's a minus 3. And the x's went away. Now, when we do the next two pieces, it should end up the same. So what can come out of the next two pieces that I've got underlined? Well, yep, look what I've got here. Don't even worry about that. What can come out of here? 5. Okay? And what is that going to leave you with if you factor out the 5? Yep, x minus 3 again, right? And that's what it should be. Are these parentheses the same again? Yes. If they are not the same, then you made a mistake. So you automatically know if those are different, you made a mistake. So now we put our x minus 3 out in front. And we have a 2x plus 5 there. And what does it still have to equal? It still, remember, equals 0. Is everyone with me so far? Now we factor it. Sorry, got it factored. So what do? We said each piece is 0. So x minus 3 equals 0. Move that 3 over. So that gives you x equals now 3. We just switched the signs. We moved it over. The other one, we've got to do a little bit of algebra on. So 2x plus 5 equals 0. Move our 5 over. So 2x equals a negative 5. We'll divide by our 2. And so x now equals a negative 5 over 2. Okay, let's look now at question 17. This one's going to be a little bit more difficult because we are going to have to divide some stuff out first. So question 17. We've got a minus 4x squared plus x equals a negative 3. So again, I'll try to let you guide me through the process. What's going to be my first step? Yep, so we're going to have to add 3. Now, if you remember, when we factored these trinomials, we never ever wanted it to begin with a negative because that just made it more complicated. So this one has a minus 4x squared, and we don't want a minus because that just makes it more confusing. So we get rid of that negative with that 4 out in front by multiplying everything by a negative. And that just switches your signs out. So if it begins with a negative on your x squared, you multiply it by a negative, and that takes care of your signs. So now we have 4x squared, we have a minus x, and we have a minus 3, and that equals now 0. What's going to go in the box? Okay, negative 12. Very good work. And where did that negative 12 came from? That came from 4 times the negative 3, right? What do we know about the signs? Are they different or are they the same? Different. Okay, and then we look in the middle. So which one's going to be the larger? Negative. Negative, always, the larger one goes first. Smaller one goes down below. What two numbers multiply together to give you 12, subtract from each other to give you 1? 4 and 3. Okay. Negative goes first, so we need a minus 4, and we need a positive 3. Is everyone okay with these so far? Now we can't just jump to our factors. We have to split the middle up and factor by grouping. So 4x squared, we've got a minus 4x. We've got a 3x, and we've got a minus 3. What can come out of the underlined part here? Yep, 4x can come out. Okay. So that 4x can come out. And what would be left over then? Yep, minus 1, right? Because the 4 came out. So that leaves you then with an x minus 1. And the next two pieces, what can come out of here? These have a what in common? 3. Okay? And if I take that 3 out, that is going to leave you with the same x minus 1. So now we've got it. Now we have x minus 1 and 4x plus 3, and that still equals 0, doesn't it? And we're almost done here. So what do we have for our two answers? Well, we've got x minus 1 equals 0. So move that 1 over. So x then equals a, switching the sign, positive 1. The other one is 4x plus 3 equals 0. Move the 3 over. And that gives you 4x now equals a negative 3. Divide by your 4. And x now equals a negative 3/4. In some cases, you may only end up with one solution. So 21 is an example of where you get only one answer. You'll actually get 2, but they're going to be the same, so it's really only 1. And I want to make sure I at least looked at one of these. So we'll do one of these, and then we should be able to do 2 of the perfect square trinomials after this. So let's look at 21. And 21 is 4x squared minus 4x plus 1 equals 0. We're in luck because it's already set to 0. So what goes in the box? 4. Now, what about the signs? Are they different or are they the same? Look at the sign of your 4. Now, how can you get a positive number? The only way you can get a positive number is a positive times another positive or a negative times another negative, right? So if that 4 is positive, you automatically know that one is that they are either both positive or both negative. And then we look in the middle. And what's the sign in the middle? Negative. So that tells me then that these are both what? Negative. And what two numbers would multiply together to give you 4, add together to give you 4? Both multiply and add together to give you 4. 2 and 2. We know they're both negatives, don't we? Notice these are the same. So we're only going to get one solution. So we split this up into 4x squared, and then we've got a minus 2x, another minus 2x, and a plus 1. First two pieces, what can come out? What's going to come out of here? Looks like a 2 and an x, right? And that is going to then leave me with 2x minus 1. Now remember, on the next one, we need to remember something. On the next one, remember, what does that begin with? That 2x begins with a negative. So we automatically know we have to factor out a negative. And nothing else can come out because 1's a 2 and 1's a 1. So we can always factor out a 1. And in this case, the negative comes out with it. So we're going to factor out a negative 1. And that would change your signs. And that would make it then 2x minus 1, wouldn't it? Are my parentheses exactly the same? Yep. So now we have 2x minus 1, gone, gone, and an additional 2x minus 1. Now, this one is easy because these are the same. And since they are the same, then what do we know? We're only going to get one answer, right? Because they're the same. It's a double root. And what would that one answer be? Well, it would be 2x minus 1 equals 0. So 2x equals 1. Okay. And divide by your 2. And so your one solution is x equals 1/2. That's it. And this is also called a perfect square trinomial. Now I factor this one by grouping, but you could also have looked at it as a perfect square. 23 is going to be the next one that we're going to look at. And 23 has these really large numbers, but I'm going to show you a shortcut that applies to question 23 and 24 as well. These are called perfect square trinomials. You will encounter them once in a while. When the numbers are huge like this, when I've got a 25 and a 9, those are really large numbers. And I really don't want to have to work with 25 times 9 because 25 times 9 would be 225. Okay, and it's a pretty large number and it wouldn't be much fun to factor. And so I look at this and see if there's something else that I can do. And I look at 25 and I look at the 9. And what do you notice about 25 and the 9 here? Well, what's special about 25? Perfect squares, right? Yep. Okay. And if you notice that the ends are perfect squares, it's what's called a perfect square trinomial. It was the same thing on the last one, but I wanted to do it by grouping, so you'd see that you get one solution. These are also going to just give you one solution. Now, these are actually very easy, because what do we know about 25x squared? Well, 25x squared can be broken up into 5x and 5x, right? And 9 is also a perfect square of 3 and 3. And this actually comes down as a square. So what's the sign going to be? Well, we go back and we look at the sign in the middle, and the sign in the middle is positive, so the positive comes down. And what did we know about 25? Well, we broke 25 up into 5x and 5x, so the 5x is going here. And what about the 9? 3. So now we've got this, and we're almost done. The perfect squares are actually the easiest ones. This is a perfect square, and we're done. We just need to get our final answer. And this is a square, so that means we only have to do it once. So we need to solve now just one of it, because we have 2 of them, but we only have to solve one. All we have to now solve is 5x plus 3 equals 0, because there's actually 2 of them here. We just have to solve one of them. So move that 3 over. 5x equals a negative 3. We'll divide by our 5. And that leaves us then with x equaling a negative 3/5. So very, very simple there. And we're going to do one more of these, and this will be our last problem. And then we'll talk about our homework. So the last problem that we're going to look at is question 24. You what now?
I just found out some really bad news.
Okay, we'll do one more here real quick, and then we'll be done here. Okay, so 24. We've got 36x squared, and then we've got a plus 60x, and then a 25. And what do we know? Well, we know these are squares, and 36 and 25 are both perfect squares. Always try to look at it as a perfect square trinomial if the numbers are larger. And in this case, they're larger, because I wouldn't want to try to take 25 times 36. So 36 is a perfect square of 6, so that's 6x and 6x. And then 25 is 5 and 5. Okay. And what do we know here? That's going to come down as a 6x. The sign in the middle comes down with it. So that's a plus there. And then we've got a 5. Almost finished here, so bear with me for just another moment or two. What does it look like now when we go to solve it? We've got 6x plus 5 equals 0. So 6x equals a negative 5. We divide by our 6, and so our one solution is negative 5/6. Okay, so what's our homework? Our homework is 1.3, you should be able to do them all, and 1.4, you should be able to do that first set. So you should be able to do 1 through 5. Okay, so 1, 3, you can do them all. 1, 4, you can do the first set, which is 0 factor, which is 1 through 5. Okay, so that's going to be your homework for Monday. And again, make sure that you check before you come to class to make sure that I don't have jury duty on Monday. I don't think that I will, but make sure that you check. If you don't see an announcement that says we're not going to have class, then plan on us having class.